Hello, everybody. Scott Roberts and Shelley Bonus here, and we're doing our first show. Our show is exciting because I think it has to do with the genius of children, you know. And Shelley Shelley, introduce yourself a little bit. Let's have a little bit of a introduction. People have been following my Facebook page, Scott in Space, but Shelley is a dear friend of mine. We've been friends since the early '90s, I believe. Is that right? Yeah. Yeah.
Yep.
And
Since what was the first Mars lander?
Viking? No.
No, Sojourner. No, what? Oh my gosh, the little one. We met at the big Space Fest in Pasadena.
Okay.
Ah, the one that looked. I can't remember the name. Oh
Well,
my
that's not
gosh.
important. What's important is that we're friends.
Yes, that's true. Mars brought us
He'll
together.
come to you. I know. You know, if you ever met Shelley, Shelley is so full of information about space exploration, astronomy. She has been session director of Mount Wilson Observatory on the 60-inch. You were with me on our last 60-inch star party that we did, which was awesome. What did you think of that particular star party? I mean, everybody's
I
looking through the 60-inch. You've looked through it a zillion times. What was your impression of that star party?
well, first of all, I thought the collection of people were spectacular.
Hmm.
Everybody bonded. They didn't know each other. They became one under the dome,
Right,
just like we are one under the dome of
right,
the sky. And my impression of the 60-inch has been thrilling for 25 years that I've got to look through it several times a week.
right.
And
Oh yeah,
and my thrill of observing is because it is never the same twice, no matter what you look at.
that's true. That's
It's
true.
so it's thrilling.
You know, I think I've only met one time out of selling telescopes and working with people with telescopes since about 1980. I met one guy one time, and he says, I've seen everything that there is to see through the telescope. I was like, really? I was going, there must be something wrong with my brain because every time I look at Orion's Nebula or Saturn or M13, you know, and I have no idea how many times I've looked at it because it's been so many times. To me, it's always fresh. It's always exciting. It's always amazing, you know. Even when
Well,
seeing conditions are bad and things are less, you know, light pollution, whatever, it's just that something's triggered in my brain that I'm looking across space and it's real and it's live, you know. So
it's live. That's the whole thing. Even the bad weather is live, and you see things in a different perspective.
yeah,
And then, you should study weather on the bad weather nights. You know what I mean? When you're looking, I know people that used to keep observing books. I mean, I did when I first started.
yeah,
And not because they're artists, but because you learn from it. The formation of the clouds. You learn about clarity, about seeing conditions when you try to see in the bad.
right.
But it's what is the most exciting thing about what we do? It is alive and it is part of us. We are it. So how could you ever be bored? And how could you be disappointed?
Right.
You should be adventurous to see it didn't look like this. It looked like this. Wow, I never saw it like that
Right.
before.
And that
Do I need glasses?
this is a nice segue to talk about this 9-year-old that's on YouTube. Now you say you've been showing this video for years, and give us a little introduction to this video. It's
Okay, well, my feeling is I was looking for various venues, various forms of explaining our concepts of the universe to
uh-huh.
people. Translate. My job has been a translator
Mm-hmm.
of understanding cosmology, astronomy, and space exploration at
Mm-hmm.
different levels.
Mm-hmm.
And when I came across this video and I heard this little boy, 9 years old,
Right.
he was the purest, the clearest, and his logic and progression, and even how he questioned things are the real questions.
Right.
We're all asking them. So I've been enamored with him, and I always wanted to actually have a child like him, or maybe three children, have a discussion with three of the top physicists.
It would be amazing.
Because
yeah.
I think the purity, if you have somebody like Kip Thorne, his purity of explanation, his clarity,
yes,
is of the universe for us. He can put it at any level because he knows it. He's pure.
Right.
This child is pure.
Right.
And when you hear what he has to say, you're going to say, "Oh yeah, that makes sense." Because some people, they want the answer.
Yeah.
This is an exploration. This is a human quest. This is a search. And the search is what's exciting, because the more you look out, the more you look in, right?
Right.
And all we're trying to do since the beginning of time is make order out of chaos.
Right. And trying to understand more about who we are. I think the kid here, I've already watched the video. It was taken by a guy named Zia Hassan. I don't know if he did a series of these things or not, but let's listen here.
Start from the beginning, because I'm trying to remember what you were saying.
So basically, the humans are on one space, one environment that's inside another environment. We are on Earth, and the Earth is just one planet in the galaxies. You could compare that to an ant on the patio in this backyard.
Let's see. Can we see any ants? Can you show me what you mean exactly?
And you kind of think this kid's going to go off into silly land, but he doesn't.
At the moment, but this is an ant horn. Anyway, so the ant doesn't know that there's more than the patio here. He just thinks there's an ant.
Oh, let's see.
He just thinks that he just keeps walking. He doesn't know he's just part of of lots of worlds.
Now, how profound is that? I mean, my God. Now, this kid continues to go on. To listen to the whole thing.
This is reflective of the parable, of 6 blind men and an elephant.
Yeah.
You see, that's an ancient parable, because human nature is what you see is what you know until you know there's more to see.
Right.
This child knows.
I'll remind you, this kid's 9, okay?
9.
So there are people who go through their whole lives and never realize this profound fact, okay? Here we go.
And the human race is sort of like that. After they've discovered what's up there, they know they're only a little part of the huge galaxy.
So do you think we're alone in the universe? Are we the only intelligent life?
This is very interesting.
I think there probably are many different kinds of life forms, cells and organisms. Some may not be visible, some may not have been discovered, and some may be on places we can't go. And they all might have the same perspective as we do on this, that there might be others, and that maybe they can find them someday, but at the moment they don't know. They're part of a big world. And
well, what do you think about the idea of alternate universes?
I think it's realistic at the same time as it is fantastical.
That's exactly what scientists think. They're not sure. They have the math to prove it, but they haven't observed it, so they don't know.
Yeah, it's just very complicated because you have no proof that there's anything out there. The only proof is yourself,
right?
And where you are in the universe.
This kid has a grasp of human psychology, cosmology, okay? The scientific method. I mean, he possesses all these things. He's sitting down here. He's playing with other kids, okay? I don't know if it's some random, maybe it's his kid or a friend of the family's or something like that. But this kid has got it. Okay, he has got it. As you said, he probably could get up with Kip Thorne and have somewhat of a debate or a conversation that.
I think conversation with really interesting questions that
Right.
both creatively can answer. And the fact that he knows there are no answers for some. Other people, grown-ups are demanding answers now, you know what I mean? And proof. And I think the exciting thing about being an astronomer, being in the field, a cosmologist, is the quest. I mean, we will have proof, but every time we think there's proof, right? If we get better technology, we either confirm what we think we know, or we got to let go, change it, and come up with something new. It's alive. That's what's so much fun.
Right. So let's listen more here.
And you can only make theories. You can never know the truth unless science gets a lot more complex and they find ways to go on to Mars or something.
Do you think we'll make it to Mars in our lifetimes?
Maybe, maybe not. It all depends if people discover it, if people try it, and basically luck.
Right.
Basically luck.
So are you going to be one of the people that tries to help find other planets and other life forms and other planets?
I might try to be. You never know for sure if there really is anything in the search. It's an endless quest without knowing what your quest is.
That's so true.
You don't know if it's.
So what's the meaning of our lives here on Earth then?
Please tell us.
That's one of the hardest questions there is. There's.
Okay. Now, again, you would think, you ask a lot of kids or adults, what's the meaning of life? Someone's going to crack a joke. Someone's going to come up with some flippant kind of thing. I think he kind of hits the nail on the head with his answer. So let's listen.
I would say what the meaning of your life is what you make it. What you think, what you want your life to be. Nobody can decide what you will do except for you.
Okay. So again, just very, very profound 9-year-old. I wish we could find him, somehow and interview this kid. Maybe we can somehow reach out to Zia Hassan and find out something. But
yes.
Now this video was made in 2013, so he's a teenager now, So it would be interesting to know. Here we go.
How he feels now.
Yeah. Control over it. You may not be lucky enough, and the odds may be against you, but there's never a definite no that you cannot do this.
So you think that we do have free will then? We can do whatever we want. It's not predestined or anything.
It may be predestined, but you can change that destiny.
Oh, well, that's tricky. But it's good to know.
I mean, I might be wrong. It might be just scheduled, like some play or something, and you act it not knowing that you're part of it. But all the same, maybe destiny's just telling you. Maybe you just know it, and that's what destiny is. Destiny is a guess of what you know, what it knows about you, and what it knows you would do. But then again, I might be wrong, and destiny could be totally in control of you, or there could be no such thing. It could just be your opinion at the time, and you could change that.
Well, it was very nice getting this lecture. I've learned a lot, and we'll pay you next time, and we'll see you next time on our show.
Okay, thank you.
Okay.
Okay, so that was. I think it goes on, and maybe there's more.
He talks to another kid, and they're playing cards. But the thing is, the truth is the truth. When it comes from the mouth of babes, we always used to say, out of the mouth of babes.
Right.
His logic is pure, and his courage is courageous. He's free. He's a
free.
free thinker at this time.
Right.
And I think he is special in how he articulates, but you will find, I find, I used to do planetarium shows, and I would find 7-year-olds or the third grade was my favorite people. Those were my peeps because the questions they asked were absolutely pure, and they were never trying to sound important or intelligent. They were pure questions. By the time they get in the 4th grade, when they ask questions in the planetarium, they try to sound like their parents.
Right.
So that organic freedom, that purity, gets a little muddled,
Yes.
But
Yes.
when children are courageous, and so their thought process is pure.
Yeah.
And so
Yeah,
aren't we like children when we're exploring? You have to be open. If you think you have the answer, how do you start the quest?
Right. Because you think you've already arrived. Yeah.
Yeah. Every place you are, you're there, right? So where are I? What am I?
Right.
How do you change? And that's what I say. When the sky is cloudy, study the clouds. It's the sky.
Right.
And it's never the same. It's alive.
Right.
When life is so amazing how we understand it. And it's limited how we understand it. And I think his answer to this question is very interesting because when we talk about is there life elsewhere, we've been having little green men images, for so long.
Oh, it's been
right?
it's been something of subjects for probably hundreds or thousands of years. That
looking for ourselves, and that's why we won't find it until we can have eyes to see something new. Why should anything anywhere else be like us? We are like us because of the criteria on the planet.
Right.
That has made us evolve this way.
Right.
Right? So.
And every one of us is as unique as a snowflake anyway. So it's but it was refreshing to listen to this kid. I encourage you, if you haven't seen the video, to try to find it. It is.
You can put the YouTube address.
Yeah, I'll get the YouTube address and post it here. In fact, you emailed it to me, so I'll copy it and put it up here right now.
But that was a great analogy about how every snowflake is unique.
It's true.
You don't see the same snowflake twice.
Yeah. Humans try to box everything in to
be safe,
categorize and explain it somehow and separate it, but when you start to realize that we're in a interrelated, everything's interrelated. There's commonality amongst, I guess, everything, and on one level, and there's uniqueness, because the recipe that made up this, whatever this entity is that you're encountering, is by its very virtue unique and at the same time. So that was an interesting subject. Shelley, you while I'm finding this link that I post here, you did send to me information about this redshift, the relativistic redshift of the star SO2 orbiting the galactic center of a supermassive black hole. And this is a deep subject. And it's on a science paper that you sent over to me.
Yes. There is there's a really brilliant professor that's been working on the black hole of the Milky Way called Sag A star for many years, and this was a team of hers and her who had been observing, I think, for the past I'm going to see, I think they've been observing, from 1995 to 2017.
Okay.
Stars that have been orbiting Sagittarius stars that have been orbiting the black hole. Okay, and the idea was, once again, to try to prove, or confirm general relativity. And they just did a series of observations of a special star that is called SO-2.
Okay.
It has a 16-year orbit, and they watched the star as it orbited around Sagittarius star, the area of the black hole, and they say they detected a combination of special relativistic and gravitational redshift qualified using the redshift parameter, and basically, once again, confirmed Einstein's theory of general relativity.
Now,
So-
why? I mean, what was the point of? What was the aha moment here with them? Is it?
Well,
it's the fact of this.
it's seeing the gravitational redshift that the gravity of the black hole, right, is how do I say? The stronger the field near the supermassive black hole, so they can see the effect of the black hole on the star.
So as the star is approaching the event horizon, because it's being drawn in by incredible.
Yeah, but it doesn't go that far to,
It does not.
to the
Okay.
event horizon.
Mhm.
No, there's nothing that I read that understood that it was that the star is going to disappear at this time in the black hole, right?
Right.
It's here. Maybe I can read this to you. The star SO2, also known as S2, has a 16-year orbit around Sagittarius A star, which asterisk star. That's what we call the black hole
Okay.
in the center of the Milky Way.
Okay.
And it allowed general relativity to be tested in a different regime, the strong field near a supermassive black hole. So it was close to the black hole, a strong field. So we're seeing where the gravitational warp is, basically, right?
Okay.
And so the supermassive black hole at the center of the Milky Way in 2018, it reached a point, the star reached a point that was closest to the distance that it had been before, which was 120 astronomical units from the black hole. That's pretty close, right?
Okay.
And it was
we would not want to be
traveling.
that close. That's for sure.
It was traveling with a velocity reaching 2.7% of the speed of light. So let me just read this to you, okay? Within 6 months interval of that date, the star also passed through a maximum and minimum velocity along the line of sight, spanning the range of 6,000 kilometers seconds in radial velocity. They presented the observations of these three events and combined them with data from 1995 to 2017. During the proximity of those passes, they saw that the supermassive black hole did cause a relativistic redshift. They saw it. It was observational.
Okay.
One is theoretical. So that's the big deal.
So this is now,
Okay.
you think about, we've imaged a black hole, and now we are, and we've had the LIGO experiment, which further validated some of Einstein's theories. And,
Yes.
and now this observation is not only fitting Einstein's theory of black holes or relativity, okay, maybe not black holes,
Yes.
but relativity.
Yes, general relativity.
General relativity. But that clue, that piece, helps us understand more of the dynamics of a black hole, right?
Yes, it helps us understand more, but these scientists think there is more than that. And so by doing these experiments, they think that eventually we might come up with another theory other than Einstein's theory that will be clearer.
I'm sure we will.
You know, and so that's very exciting because
theories are kind of
this
like
is
stepping
saying,
stones, whether this theory holds water or not. it's up to observational astronomy or some sort of way of detecting something. And the guys that come up with, who developed the experiments with those people are amazing in themselves. They're like, oh, well, you got the mathematicians saying, we should, if that's true, we should be able to find this. And then
Yes.
you've got to develop the experiment. They develop an experiment. Then the people running the equipment collect the data. If they collect data that kind of matches that, okay, doesn't necessarily make it absolutely true, okay, doesn't make a fact, okay, but it adds tantalizing, credibility and more weight to the theory, Now, it may be that we get a surprise observation later on, which often happens, and then they go, wow, that can't be true anymore, okay, and then that blows away the theory, then they start all over again, so. But we have people do with overlapping theories, and so it's that is the process of science,
Of course, that's what's exciting about it. And now there's been, in 2011, there were two teams that combined, and they determined, they won the Nobel Prize, astrophysicists, for determining that the expansion of the universe, that the universe was expanding, but also that the expansion was speeding up. Mm-hmm. And they were trying to determine what the rate is. So the big holy grail for cosmology is what is the rate of the Hubble constant, right?
Yeah.
And it's been challenged again. And it's very interesting because the teams that are challenging this decision are saying, first they said, could it have been the equipment?
Mm-hmm.
Could it have been the computer? What has caused the difference? And the search is on again. And perhaps, the technology will improve because the scientists, they check the figures, both teams, they're racking their brains, but they have found an anomaly. This is exciting.
Yes.
This is exciting.
Very much so. Very much
I just say, do that, but don't be late for dinner.
So, again, I will probably at the end of the show, I'll put a post where this PDF is so that you can read about it yourself. But even if this might be not really, dinner table conversation.
I can't hear you. It's all staticky.
All staticky. Okay.
Yeah.
All right. Maybe we've lost something here. Well, I'll wrap up the show then. Okay. I'll wrap up the show. Thank you for tuning in, and maybe we had a little technical difficulties. So, anyways,
finding our way.
Shelley, thank you very much, and watch our next show. Take care.
Clear skies. Bye-bye.
Bye-bye.